Testing. Hello, this is Benjamin, and this is what I've done for my second database project. I got 3 phases to show you. First, the database design, the database implementation, and the SQL queries and reporting. So let's get started. First, we got the conceptual model. So out of all the tables that we've got in our business rules, this is what I've determined to be the parent tables. We've got the credential, student, course, and instructor. So for one, I figured a student can have more than one credential if they're applying to a certain school. The credential could also have multiple students having that same credential. That credential could have the same course, also vice versa. The course could also have many credentials for it. So an example of a course would be math, because obviously there'd be more than one credential taking that course. This course also could have prerequisites, which is why it loops back to itself. And the course will obviously have an instructor, one or more instructors for teaching the same course. It also goes the other way around, where an instructor could teach more than one course. A student can have multiple different courses, while a course can also have multiple students taking that same thing. Anyways, on to our logical model. Now, this is after I've placed the attributes, the entities, and got rid of the many-to-many relationships. Student credential, that relationship is turned into an entity called student credential, both of their primary keys, and turns it into a composite, which has a start date and an end date when they graduate, and a GPA and their current status. Their student also have a course record, so this is like listing all the different courses with their CRN, semester codes, and their ID, so that way the student is attached to it. Scheduled course would be what the student is taking, so this would also include the instructor, which would be teaching the specific course, and the scheduled course also takes its information from the parent table course. That's how instructor and course are connected. A course and credential, they're connected through linkages. So this is just determining the requirements, whether a course is required or not for a specific credential. Now I go to the physical model. I placed some constraints around here, so let's give it a check. For the student, we can determine 4 types of students. So an active student, a student in academic probation, suspension, or they're expelled. They also need a date associated with that status, so I've included that as well. Format must also be just like a phone number, and same as the email. You can have 6 different types of credentials. You have micro, fast track, certificate, diploma, applied degree, and a degree. Under a student credential, they have active, granted, and expired for their credential status. And they also have a GPA attached to that, which must be between 0 and 4, because that's how the score works. And start date must come before completion. Your course code is also set up like this, and your number of credits between 1 to 9. For linkages, since it's a Boolean value, it's set to 0 and 1. 1 being a required course, and 0 for an optional course. That's how you'd figure it out. Semester code is set up by the year, and then the semester. Then the format of the course code is also pulled from the course, so it have the same format. And section code is in alphabetical order. Then lastly, you have a provincial code, so it must be a provincial code. So Alberta, it would be AB. Postal code, you would have the similar letter, number format. Phone number and email, as per usual. That's the physical model. Take a look at my sample values. That's a hefty amount. I asked ChatGPT to generate me some sample data, which, as you can see here, I've got data for every single table in my database. Then I made a Python file which takes these CSV files and drops it into my tables. So here, let's give it a try. First look, we got no tables on our database. Now with the create file, once I make it, now I got my tables. Got no tables. There it is. There we have our attributes on here and the table. But now where's our information? That's where this population file comes in. Now, so if we take a look again, now they're all filled with information. On our database, this is what our ERD looks like. We've got student credential tied together with the student credential. We've got course record as well, connected, scheduled course, instructor, course. This is connected via the scheduled course. Course credential connected by linkages. Course also has a prerequisite looping back on itself, and then we got student course record pulling off of the other different courses. Now, let's go on to the queries. Just a quick note, even though I'm running these SQL files under VS Code using SQL tools, these are still possible to do under PostgreSQL. You can see the screenshots under the files that I sent on D2L. Now, the queries. We've got report 1. This would basically restrict your data to show only instructors currently in Alberta. We have the instructor ID. We have concatenation. So this is like first name and last name put together. So you have it all in one column. And their contact information as well as their province, since they're all from Alberta. Now with the second, this lists all the students with their enrolled courses. And the purpose of this would be to check inactive students. I'm starting off with aliases here. So pulling from student, we have student ID, first name and last name, and course code, which is pulled from our student course record, which we label with the alias table 2. So with a full outer join, this basically returns all the data matching from both tables and puts it all together. So you'll basically see the students, the courses they're attached to, as well as students who are not currently taking any courses at all. From this, it would be useful to see any students who are not active in taking their courses, as well as courses that are basically inactive. With the left join, it will join all data from the left and match with the right. So I can see this is where student credential starts, and we've got credential on the other side. So we got what exactly the credential number is. So we got the school Hamilton Werner, and specifically for production, TV and radio. Then we got filters added to ensure that the credential is only number 25 and they're already complete. So these are basically students that have already completed credential number 25. And this is done through chronological order, as you can see. Now for our fourth report. The purpose of this one is to query for students with an A+ on a course alongside their name. We got an inner join. This joins the student course record with the student through student ID. And that's how we're able to put these two tables into one. It filters for students specifically with the A+, as you can see here. It organizes through the course code and student IDs, so it's in numerical order. Number 5 talks about the number of students that are enrolled in a credential per year. So first we pull the start date using extract. It counts the total number of students per year, and that's how we get this column on the right. The roll-up here groups the data by year and also adds an extra row showing the grand total of the students. Then we also set it to chronological order, so from earliest to latest. The purpose of this query is to find all the possible combinations of courses per credential. This would be useful for somebody setting up the curriculum, so that way they'd figure out what courses are missing and what needs to be required for these certain credentials. First, we changed the Boolean values to strings so you can easily tell which it's optional or required. Then it will count the total rows per course. Cube would basically create all the possible combinations. As you can see here, it just repeats the same process. And here we've got the grand total as well. 76 optional courses, 224 required, and 300 as a grand total. Our seventh one touches on GPA as it finds the top student in each credential. So first it takes the credential number, GPA, student ID, and merges the two names into one column as student name. Then it will join student and student credential together, so that way we can set up the table. Next, the purpose of this is to get the highest GPA of all the students. Here you can see order by credential number, right? So numerical order, and you can see who is sitting at the highest GPA in those specific credentials. Now lastly, this one talks about the number of courses that each student is enrolled in. First to count, this is a subquery. It will count the total course for each student, and it attaches itself to the student ID. From most to least, you'll see 7 to 0. Anyways, this is Benjamin. This is my work for Project 2, Database Modeling and Reporting Project. Thanks for watching. Anyways, I'm out.